Number 9. The amount of detergent dispensed into bottles of liquid laundry detergent bottles for a particular brand is normally distributed with a mean of 85.9 ounces with a standard deviation of 1.15 ounces. If 16 bottles are randomly chosen from the factory, what is the probability that the mean fill is more than 86.9 ounces? Now, in order to do this, let's just draw a distribution and try and organize the information that we're given. So this is not a standard normal distribution, this is just a normal distribution, but the mean is always located at the center. So I'll put the mean of 85.9 ounces right in the center. Now, the mean is provided as that. The standard deviation, however, for this particular distribution, what we have to keep in mind is we're dealing with a sample of 16 bottles. So even though the standard deviation begins with 1.15, we have to divide that by 16. I'm sorry, the square root of 16 to make up for the difference of using a sample of items. Now, where to put the other information? So we want the probability that the mean fill is more than 86.9 ounces. So that's larger than 85.9, so I'm just going to put that somewhere to the right of 85.9. So 86.9 is right there is what I will say. So essentially, I want to figure out what this area is underneath that normal distribution curve. In order to do that, I'm going to use the calculator with the function normal CDF, because that's the function that calculates area underneath the normal distribution curve. I'm going to go from 86.9 up to positive infinity, but in this case I'll just use 10,000 to represent positive infinity. The mean is 85.9, and the standard deviation is 1.15 divided by the square root of 16. That's what I'm going to put into the calculator, and let's see what answer we come up with. So second distribution, normal CDF, 86.9, comma, 10,000, comma, 85.9, and then 1.15 divided by the square root of 86.9, I'm sorry, 16. So I get 2.5238 and some more digits, then E minus 4. So let's just write that down. So 2.5239, I'll say, E minus 4. So this is something that you should have seen enough in this class already that you know that this is just the way the calculator presents scientific notation. So essentially it means, 2.5239 times 10 to the negative fourth power. So we just need to move the decimal places 4 places to the left. So 0.0025239. And if I round that to 4 decimal places, as we normally do, that's going to make it 0.0003 is that probability. So that's what that area there represents. Clearly it's not to scale, but the concept of just making sure you're shading to the left, shading to the right in the proper situations, that's what your sketch is all about. Now, the second part to this question is, if 16 randomly selected bottles had a mean of 86.9 ounces, should the machine dispensing the detergent be recalibrated? So, there's a 0.0003 probability that that should occur. So if we're on the production line and we found 16 bottles chosen randomly, and the mean of those bottles is 86.9, that shouldn't really happen. There's a far smaller chance than a 1% chance than this should occur. So there's probably something wrong with the machine. In fact, let me bring up a scaled drawing of this distribution. Okay, so there's a scaled drawing. My sketch was not scaled. I have 85.9 as my mean, and then using the standard deviation, which was 1.15 divided by the square root of 16, turns out to be a fairly small number. So if you estimate that with a calculator, 1.15 divided by the square root of 16, it's about 0.3. So if you notice, the distance from 85.9 to 86.2 is 0.3, and then 0.3 again, and so forth. So 86.9 is like right here. So the area to the right of that is extremely small. Scaled, you're just not even seeing a whole lot of area. So that's why this probability is so small, 0.003. And to that effect, if you find 16 randomly selected bottles and their mean is 86.9, but there's such a small probability that should occur, the machine definitely is going to need to be recalibrated. So, yes.